So let's look at a problem that's a little bit harder, and also we're going to do a little bit more with it. Okay. So this one is factored for me. That is the best scenario. Okay? Hang on a sec. Remember the first one that we did? We had to factor it. Okay? That's fine as long as the highest power is a 2. I can factor it. But when the highest power becomes more than a 2, I start having trouble being able to factor. So I would really like for them to give me the problems already factored. It makes it really easy. All right, so if I want to find the zeros, remember that I'm finding the x-intercepts. Remember that I'm setting the equation equal to 0. Okay, and once that's done, I have to write this out again, but I'm going to jot it right here. Once I've set it equal to 0, what's my next step?
Would you multiply it out, or?
I don't want to multiply it out because it's going to take me like the rest of the day, right?
Yeah.
I don't think I want to multiply it out. I don't know that I need to. All right, let me go back for just a second. Let's go back to that problem. Okay, so when we got it factored, which is where we're at right now, what was the next step? Put the factors, and we set them equal to 0, right? Okay, so I'm going to do that same thing over here. So I'm going to take my factors, and I'm going to set them equal to 0. All right, so I'm going to take the x minus 2, set it equal to 0. Take the 1/2, x minus 1/2, set it equal to 0. Take the x plus 3. Set it equal to 0. All right, now I'm going to ignore the 5 in the front because there's no way that 5 can equal 0. All right, so it's just kind of like an extra number there. Okay, so what are we going to get? Solve them. So I'm going to add 2 here. So I'm going to get x is equal to 2 as a 0. I'm going to add 1/2 here. So x is equal to 1/2. I'll subtract 3 here. So x is equal to -3. And I can check that. I put the graph over there just so you can kind of do a quick check. Make sure that that looks reasonable. All right, -3 is sitting right here. +2 is right here. And this is going to be the 1/2. Okay, everybody okay with that? So let me ask you this. What's the degree on this? Okay, so let me write my zeros down so I don't lose them, and then I'm going to erase. Okay, so what you want to keep in mind with the exponents is that those exponents tell you, like, what does it mean that x minus 1/2 is raised to the 3rd power? That means that there is 3 of those. So this function really looks like this. And then the x plus 3 to the 4th means that there's 4 of those. Okay, so that is like fully expanded. Now, help me with the degree. I told you for the degree that the easiest thing to do was for you to count the x's, right? So how many x's do we have once I've sort of expanded this thing out?
8.
8. Okay, so the degree is 8. Now, let me think how I could have gotten that if I didn't want to write it out like that. I could have said, here's a 3, here's a 4. I know that there's a 1 right here. So 3, 4, and 1 make 8. So I could have done it that way, right? Simply adding up those exponents. Again, the 5 doesn't really come into play because it's just a constant sitting in front of the terms. All right, so I'm supposed to have, for how many zeros, I'm supposed to have 8. Remember that the degree and the number of zeros are supposed to be equal. So do I have 8 zeros? Yes, but I've got some duplicates. Okay, so I have the x minus 2, which is going to give me that 2. Then I have 3 of these. So I actually have 3 1/2. Right? And then the negative 3 is coming out of this first one here. But I have 3 more. Right, so that's how I end up with 8 zeros, because I have to consider the fact that some of them are occurring more than once. Right? Everybody okay with that? Okay. So, the next thing I want to show you is we're going to kind of summarize this a little bit as we go. All right, so we're going to use a term called multiplicity, which you may or may not have seen before in another algebra class. Multiplicity tells me how many times each zero occurs. All right, so I'm going to do a little chart here. I'm going to put the 0, and then I'm going to write the multiplicity next to it. All right, so I'm going to list my zeros. So I have x is equal to 2. That's a 0. I have x is equal to 1/2. That's a 0. And I have x is equal to negative 3. And then the multiplicity is going to tell me how many times that 0 occurs in the list. Right, so when I look up here at my list of zeros, how many times do I have 2? I just have that once, right? And so I'm going to put a 1 for the multiplicity. Right, how many times do I have 1/2? I have that 3 times in the list. So that has a multiplicity of 3. And then the negative 3, it's listed 1, 2, 3, 4 times. So it has a multiplicity of 4. And then we're going to note whether that multiplicity number is even or odd. So 1 is an odd number. 3 is an odd number. 4 is an even number. And the reason that I want to note whether it's even or odd is because that's going to tell me what the graph is going to do. So I'm going to add one more column over here for the graph. All right, so if we have an even multiplicity, I'm just going to jot that up here. If we have even multiplicity, the graph should touch the x-axis. Okay, it doesn't cross it, but it should touch it. If we have odd multiplicity, the graph should cross it. You can sort of follow this by looking at the graph. All right, so our first one is odd. So that means that the graph
crosses the x-axis.
crosses the x-axis at x is equal to 2. Right, and you can see that it does that. It goes across right here, okay? Coming in on one side and then going to the other side. All right, the next one is also odd. So that means, again, that the graph crosses the x-axis at the 0. So at 1/2, it should also cross, which I can see that it does. And then at the -3, because that's an even multiplicity, the graph should touch the x-axis, not cross it, but kind of touch it and then turn around and go back up. Okay, so we're going to look at some other examples, and I know that's kind of a lot of things all at the same time. Anybody have a question or you need to clarify anything? Okay, all right, so let's kind of keep plugging away at it. Let's try a different example. All right, so we have for our example, f of x is equal to x squared times x minus 2. Okay, so the first thing that they want is the degree. All right, so what do you guys think about the degree? Anybody have a feel for what that would be?
3.
3. Okay, so you're kind of keeping in mind that x squared is x times x. You got 2 x's there, and then you got a third one sitting right here. Okay, so the degree would be 3. I would expect to have 3 zeros. All right, so let's look at finding those zeros. So remember that in order to find the zeros, you're going to set your function equal to 0. You're going to say, yay, it's already factored. That makes it so much easier for me to do. All right, and then you're going to take each of those factors and set them equal to 0. So we're going to do the x squared. And then we're going to do the x minus 2. Now, the x squared is different than like the 5 in the other problem. Okay, we don't deal with just regular numbers, but if it's got an x in it, it's one of the terms. So we'll put that in there. Right, so x squared is equal to 0. X minus 2 is equal to 0. All right, and let's figure out what those zeros are. So the only way that I can have something squared and have it be 0 is if it's 0. So that's one of them. And then on the other one, we're going to add 2 to both sides. And that'll be the other one. Again, remember, we said 3, but we're going to have some duplicates. All right, so what is the multiplicity on the 0? How many times does that 0 occur?
Twice.
Okay, and the easiest way for you to get the multiplicity is to look at that exponent. So on that term, it has a power of 2. That means the multiplicity is 2. 2 is even. Oops, there's the other spot. 2 is even. Right, which means what's going to happen on the graph?
It's going to touch.
Going to touch. Okay, so I'm going to say that the graph touches the x-axis at that 0. Okay, so at x is equal to 0. All right, what about the 2? What's the multiplicity on the 2? Again, I'm using my exponents, and when I look at my function up here, I don't see any exponent, and so I know that there's a 1 sitting right there beside that. All right, so I'm going to put 1 down as the multiplicity. All right, so there goes my 3 zeros. I have 2 zeros and 1 2. All right, 1 is odd. So the graph should cross at that point. All right, anybody have a question there? Okay, so let's try one more. All right, so our luck kind of ran out here because this one is not factored. Right, so I know that that has to be the first thing that I do is try to get it in some kind of factored form so that I can work with the problem. Right, so I can go ahead and say that the degree on this one would be what?
4.
4, and then it would have 4 zeros. So that part's not too bad. And I know that I'm supposed to set this equal to 0. Okay, so think about how you factor. The only thing we've done this year in terms of factoring has been with a quadratic where we did the double parentheses. Right? But you want to keep in mind that the easiest way to factor is first to get rid of to pull anything that's common to the front. So let's look at it from that angle. Is there anything common between x to the 4th and 3x to the 3rd and 4x squared? Anything? And then if I take an x squared out of an x squared, it just kind of goes away and leaves me the 4. Okay, so I'm feeling a little better because when I look at that part that's inside the parentheses, I'm saying to myself, okay, that's a quadratic. So now I'm hoping that I can factor that x squared minus 3x minus 4. Right, I'm thinking x and x for sure. All right,
4 and 1.
Yeah, 4 and 1 would make the 3. Okay, I want the 3 to be negative, so that means my bigger term needs to be negative. Other one needs to be positive. Okay, so now I have a factor. All right, so what I want you to do for me real quick is see if you can fill in the chart. Okay, so go through and see if you can list out the zeros and talk about the multiplicity. All right, I'm gonna give you just a minute or two and then we'll check. All right, so I'm gonna take each of those 3 terms, set them equal to 0. Do you agree with 0, 4, and -1? Anybody have any trouble with those 3? Okay. All right, so let's put the multiplicity in. Okay, so I am looking right here. All right, so what's the multiplicity on the 0?
2.
2. Okay, it's coming from right here, right? Okay, 2 is even, so the graph should touch. All right, what about on the 4?
1.
Yeah, there doesn't appear to be an exponent at all, so we assume that there's a 1 sitting there. All right, same thing on the 1. We don't see an exponent, so we assume it's going to be a 1. So 1 is odd. So the graph should cross the x-axis. At 4 and at -1.